The Mizzou Space Program competes in a few different high-powered rocketry competitions, including the Spaceport America Cup in New Mexico. MSP has competed in the 10,000-foot SRAD motor category, so that means we were aiming for a 10,000-foot apogee, the highest altitude. You get a higher score if you get closer to that apogee. If you go a little above or a little below, you get points deducted. Our Capstone group is working on an airbrake system as a proof of concept that MSP can innovate upon and use for future competition rockets and get higher scores because they can reach closer altitudes to their target altitude.
This is the very first prototype that we actually printed at the Mizzou 3D printing lab, which is in Lafferty. All the Capstone students can use the 3D printing lab, and we just sent them the 3D CAD files and they printed it out for us, and you can see it even moves.
We chose this project because we wanted something that we could focus on the design portion, the testing portion, manufacturing, and then continue making iterations throughout that entire process.
As wind comes around the tip of this rocket, it's going to hit our air brakes once they deploy and slow down the rocket. Now, how much it slows down the rocket depends somewhat on the velocity. So the way we tested it is we strapped this rocket to the top of a car and drove around safely at different speeds in a park. And we can measure the deflection on the spin using an electrical sensor. And from that, you can figure out the force.
The outcome of our Capstone project was that we were able to create a first prototype of our air brakes for the rocket, and now MSP can take our designs and our software and continue developing for their competition.